they don't really interact with layer 7 directly. They're usually above the application. When you look at layer 7, to a network engineer, this is just data coming in, but to a backend engineer, they're using different libraries and listening. They're sending packets, and the packets they're using maybe a gRPC protocol or certain protocol that sits on top of HTTP2, which creates more packets. But that's the application, and that's really what's really critical here. The application is really huge here, and everyone's looking just at that layer differently. But to us, anything above, effectively the HTTP is the application, or FTP or gRPC, anything here at this layer. This is the actual application. Layer 6, the presentation layer, encode serialization. Ever send a JSON, right, through Fetch or Axios? The JSON need to be serialized from this JSON object, if you're JavaScript, or Python, if you're like a bunch of arrays or that data structure, down to a string. And this is happening in layer 6. While you shouldn't care about this is already happening for you. So it's a little bit a step down from your application. Your application sends a whole object, but the conversion of the encoding happens there. Serialization, this is a UTF-8, whatever, let's encode it so the underneath layer does the job. That's why talking about this stuff is like, you might say, wait a minute, I say, who cares, right? You might say, who cares? Like, I want encoding and serialization. This is happening in my application. And that's what people are frustrated about the OSI model. People's like, really, you really need to break that fine of a level of detail. I don't care, Sometimes this is one of the presentation layer and also the session layer at some cases, That's why the TCP IP model kind of simplifies this. But I still prefer the OSI model, just an FYI, because we're used to it. Back to the slides. So that's the presentation layer. Then we have the session layer. The session layer is where TLS happen, where connection establishment happen, where state effectively sets place, where you store a state in the client, where you store a state in the server. That's why some protocols go stateful, versus stateless. HTTP doesn't have a session layer because it's a stateless protocol, While TCP, it is a stateful protocol. You store a state on the server and a state on the client, and you manage a session effectively. And if the session is destroyed, effectively either you can restart the connection or invalidate. So the session layer actually effectively checks that. Again, a lot of people says, really, you want? It's like, really, session layer? Really need a whole layer just to talk about session? Believe me, this layer is actually important. A lot of proxies, like Linkerd, you've actually built logic only at the session layer. Only at the connection establishment, they would do certain logic. So their application is a layer 5 app, because they capture a connection and save it or do pooling about it, So that is a layer 5 app. That's what it means. Like, your application is layer 7. Oh, this is a layer 7 proxy. This is a layer 4 proxy. We're going to talk about this in a minute. All right. Transport, one of the most important ones. Let's be honest. Layer 4 and layer 7 as a backend engineer, that's the only two things that you're going to worry about most of the time. Maybe if you go and a little bit DevOpsy, you're going to care about layer 3 and layer 2 when you build like VRRP sessions and work with Keep Alive and stuff like that. We don't worry about this. But we live here, baby. We live in layer 4 and layer 7 most of the time. We build layer 4. We configure, doesn't necessarily be building, but we configure our application to be a layer 4 app. Why? What does that mean? It means we're aware of the transport. It means we're aware of the packets, right? They're not called packets. They're called segments when it's called TCP, and datagrams when it's called DDP, right? Let's be very specific about these namings in a minute. You're gonna across the course, you're gonna worry about this and understanding it very clearly. But this is what it is effectively. TCP UDP, right? Very, very important concept. The protocols live here. These are the only two protocols. Let's be honest. There aren't any other protocols when it comes to transport. Well, you can call it count quick as part of this. It's a very new quick protocols. Roughly new, but it's a transport protocol. But that's pretty much it. These are the three protocols, and everything is built on top of them. HTTP built on top of TCP. HTTP2, TCP. HTTP3, Quick is built on UDP. So everything is built on either eventually TCP or UDP. There aren't anything else. You can be fancy and build application directly on the IP, which is layer 3, the IP protocol, the internet protocol. Here we don't have a transport concept. I don't care about if the packet reaches or not. I'll try my best. I'll tell you if it's bad. But hey, it's up to you. It's a network protocol. It's a packet that's destined to an IP. Here we have visibility to ports. Port 80, port 8080. Here we don't know what ports are. We only know addresses, IP addresses. So every layer has kind of a beautiful concept introduced with it. So the IP have the concept of the routing and the IP addresses, which we're going to explain in the whole section. So stay tuned. Beautiful stuff coming. So layer 2, another important concept here. Layer 2 is the data link layer, and we're dealing here with the physical medium at the end of the day. Physical network addresses. Hey, this Wi-Fi has this MAC address. I want to send a frame to it. So we're sending a frame in layer 2, and we don't know about IP addresses at this layer. Nothing. We only know about MAC addresses. We only know about that's pretty much it. And the protocol that we use, like Ethernet, Wi-Fi 802, whatever it's called. Frames. We send frames in layer 2. I'm going to repeat this 1,000,000 times during the course. We send frames in layer 2. We send packets in layer 3, and we send segments in TCP layer 4, and we send direct rounds when it comes to DP. Also called segments for both. You can sue me if this is not correct. Right? But yeah, don't worry about the terminology a lot. Physical layer. This is the bare metal. Once you take the frame, how does it transport to the other medium? Electric signal when it comes to Ethernet? Is it fiber, light waves? Is it radio waves? Wi-Fi or LTE? All this stuff. The physical. And when it comes to this, it's just radio waves at the end of the day, light, electricity. But eventually, someone needs to convert that electric signal back to a layer 2 frame. Well, first it converts it to a bunch of digital 101010, and then converts it back to frame, which then the frame converts to IP, which then the IP, we take that piece of the data and we understand the TCP segment, and then we understand, do we have a session here? We need a state in this case, and do I need to decode, serialize, and deliver to the application so you can serve your beautiful HTTP GET request, for example. Here's an example, actually, from the point of view of a sender. We're sending a post request, and I specifically did a post because I need to send body, and we cannot send body with GET request, right? So we have to do a post. So I'm sending a post request to an HTTPS web page here. HTTPS means it's encrypted, so there's TLS here, but we'll come to that. The application post request with the JSON data to HTTPS server. That's what the application does. So you use Axios, or you use Fetch, or you use your Python request library, and you send a post request with this blob of JSON. You say, hey, send it. The presentation layer takes your JSON object, which is just an object here, and serialize it to flat byte strings, right? Because you're going to send an object, it doesn't mean anything, right? An object is meaningful in your language only. It doesn't mean anything when it comes to, it's a string. You need to convert it to bytes, right? And shove this bytes as a bunch of data here. So now we have this JSON, and we have the protocol. We have other stuff as well, information. The session here, do I need to establish a TCP connection? Do I need to establish TLS? Yes and yes, yes and yes. We establish a TCP connection because we need to communicate. We're going to explain all this beautiful stuff. We're going to explain how to establish a TCP connection. What is TLS we need here in a minute, right? So the encryption that happens. So we have, this is what happened in session, where you need to store a state. Transport, send the SYN request, target 443. So that's the actual first thing that we send, right? This is a direct command from session layer, because to establish a connection, you need to send the SYN ACK, right? We're going to talk about this. Don't worry if it's confusing. But don't send the data here. Send just the SYN request. We're paused here. The JSON doesn't go away. Doesn't go to the other party yet because we don't have a connection yet. So you establish a connection, you receive a connection request, and you authenticate, and then you send the data here. But let's just say I'm just sending the SYN request for a minute here. The SYN is sent to port 443. Why? Because the transport understands what ports are. Why 443? Well, you said HTTPS, and that's the default port for 443. We understand 443 is the port for this. And the network layer, which is we shove that SYN request, which is a segment, down to an IP packet, and add the source and destination IP. So if you need the IP address, you need to do a DNS to get the IP address. Once you get the IP address, we shove it into this packet. Well, don't worry, we're going to have a beautiful diagram to explain all that stuff. But data link each packet goes into a single frame and adds the source and destination MAC address. So we need to figure out the MAC as well. That's R. We're going to talk about it. Each frame becomes a string of bits, the physical layer. Just 10, 10, 10, 10, 10. These 10 zeros are converted into this radio signal or electric signal or light, and of salt. Whatever we explain it here doesn't have to be clear cut and dry, as they say. Some layers can inherit from each other and do this stuff. At the end of the day, human built this. Nothing is just layer 4 or layer 5. You can argue about any of that stuff. Receiver. What does the receiver do? The receiver will receive the physical layer first, right? Hey, we received a bunch of radio or electrical light, right? Because your server might be on fiber, but your network, you can have sent it from Wi-Fi. See the beauty, guys? Do you see the beauty of this? I can send your data from Wi-Fi, right? And then you receive it through fiber. You might say, duh, but I absolutely appreciate this. So now the physical layer at the receiver side converts this to digital bits, and then the data link, the bits from layer 1 are assembled to frames. The frames from layer 2 are assembled to an IP packet. Now IP packet, I know the destination IP address. Is this for me? Yes, it is, right? And every router, by the way, asks the same question. I'm going to come to that. Like, is this packet for me? So the transport, the IP packets from layer 3 are assembled to TCP segments, Right? And then deals with congestion controls of flow controls and transmission. And hey, is this the sequence? Is this the rice packet? Is this the old packet? Is this a new? And order, all that stuff. If the segment is a sin, we don't need to go any further into more layers as we are still processing the connection request. Here's the beauty here, right? Since it's the connection request, we don't really go down. There's no point to go down to the session layer. Well, we have to go to the session layer here to establish the connection. And once we have the connection, we're going to have our JSON back in this next request. And then we're going to go all the way to the connection here. Then we're going to go to the deserial. We're going to do the presentation layer. Deserialize that flag byte string JSON back to the JSON object for the app to consume. And the deserialization here could be completely different from the deserialization that happened on the client. Because you can serialize from JavaScript but deserialize into Python. Or you can serialize from C# and deserialize into Go. It doesn't matter. And that's where your logic is. That's why a lot of people say, really, the presentation application layer is just the application, to be honest. Like, this is my application is doing this logic at the end of the day. And you can argue with that, of course. Again, take a look at yourself. The application understands the JSON post request and says, hey, your express JSON or Apache request at the end of the day, receive the event, and it will trigger that event to say, hey, someone just sent you a post request. What do you want to do with it? That function that will get called, it will be triggered and say, hey, someone just sent you a request. You can consume that request, go to the database, do something, and then get back synchronously, and this response back to the client. All right, finally, some diagrams. So this diagram took me a while to build. Let's see if you guys like it. So the first thing, client. So the client and the server. Notice that arrow will go down or going up. That means the client is the sender in this case, and the server is the receiver. Doesn't mean that the server doesn't send data. It also can absolutely send data. So the application layer goes to the presentation. We talked about it. Serialization, decoding, encoding, all that jazz. Session layer, establishing a connection, whether this TLS or the handshake itself, the TCP handshake. Establishing the concept of a connection, a stateful thing. Then transport. Actually working with the TCP flow control in the ports and all that jazz, the actual segments. Go down, network, right? The IP packets itself. Go down, data link. This is yellow, this is orange. I don't know if it's clear. Hopefully it's clear. Hopefully I don't regret the choice of these colors. The physical layer, which is the actual medium. And then we send it. And I chose the waves in this case. The server receives it. We received it first from the physical medium because that's how you receive things, The lowest layer, your network card receives this signal and then convert it to the data link and then convert it back to the IP address, IP packet. All the way to transport, then session, go to the presentation and go all that way. So you just, you see the mouse, right? And then go all the way up. It's like this. It's you. So the question is, do I have to always go through all these layers? Absolutely not. I'll give you an example. If you send a TCP, let's go. I'm sending an HTTP post request, but I need to establish a new connection. Well, the application sends the request, The presentation does the JSON thing. The session poses the presentation. I said, wait a minute. Session. I don't have a session here. What are you talking about? Let me create a session. Wait for it. Wait a minute. Just let me create a session real quick. So we go, send the send request. We send that send request to create a connection. Goes all the way here. You're seeing this pointer. Like, this is important to see the point. Otherwise, the whole thing is pointless. You see, go reach the session. Okay, I agree. I'm going to create a connection. We don't go up. There's no point. There's no application yet. This is just a request to send a request to send a connection here, to establish a connection. And then we establish, okay, send ACK. Go back and send. Okay, I receive your send ACK. Let me finally do an ACK. Go back and then boom. Stop here. Session. Now we have a full connection. Now the session will say, okay, now that we sent the ACK, you may unlock and go further. Or you have now a session, continue. Remember the post JSON request is now resumed. Go to the transport layer. Or let me put it in a segment. This is you put your byte string JSON to the transport layer, shove it into an IP packet, determine the IP address, the destination, shove it into the data link, determine the MAC address. Obviously, we already determined all that stuff in the handshake, but I'm just explaining here again. And then send the physical layer, all the data, transport, all the way to the transport layer. You have the session. Yes, you do. Presentation layer. What do? I have the beautiful JSON. I have all this data, and this could be a single packet or segment, if you will, or multiples. So this will do the assemblage. We'll assemble all the packets that are necessary and then deliver one huge string to the presentation layer, which will decode it or deserialize it, go back to the application, and all of a sudden, you just triggered that listen, not listen, what's it called? The post router, if you will, if you're using Express.js here. Just that. Now it's triggered. So look at the work that is happening, guys. And that is the purpose of this course. Understand what is happening. And there's beauty of understanding. I don't know what that means, but you get the point. All right, so this is a segment. This is the packet. And this is a frame. I'm going to repeat that a million times until this is a hammer. Frame, packet, segment. Very critical to understand. This is another view that I like to do. I personally do. I've never seen anyone do something like this before. This is how I understand it. Not necessarily this is how it looks like in the wire, if you will, or this is how I look. I look at this as this is the Russian Matrushka. If you are aware of this nodes inside the node. This is exactly what OSI model is. You have the application, you go to the presentation layer, go to the session layer, and the content here goes into a TCP segment. You add the destination port and the source port, left and right, but not necessarily left and right. It's just literally at the end. But I like it to do it this way because I understand it better. And then this green segment shoves into an IP packet, and that IP packet now we have to add the destination IP address and the source IP address. And then the whole IP packet gets shoved into a frame. And boy, it better fits into a frame. And we're going to talk about the frame size called an NTU, maximum transmission unit. You cannot put an IP packet into multiple frames unless you fragment, which is something we're going to talk about in the future. Destination MAC and the source MAC, you put that, and then the whole thing becomes just a straight blob of radio signals. And we're going to do the same thing. Hey, get the bits, right, from the physical layer. Understand where the frame starts, where the frame ends, because that's what the physical layer does. And actually, layer 2, they're doing this that for you. And now, hey, we have the MAC address here. We have the source MAC. Take the data portion of this frame. That becomes the IP packet. Hey, there's a destination IP. This is source IP. Here, you don't see this. This is shoved here, down into that frame, right?